Today, guys, we're going to be starting our concept called perpendicular vectors. Now, we're used to seeing vectors in two dimensions. So you guys can pretty easily see that these vectors right here would be considered perpendicular. All right? What if I had one, though, that went this way? That goes what? Down 3 and over 4. If that goes down 3 and over 4, this one would have to go up 4 and over 3. You guys remember that from algebra, that perpendicular lines are negative reciprocals of each other. Let's check a protractor here. If I put a protractor right there, you guys see how that's 90 degrees right there? If I take the protractor right here and I rotate it, that also is 90 degrees. Right? These are right here. So both these are examples of vectors that are what? On a two-dimensional plane that are perpendicular to each other. What I'd like you guys to do right now is let's put problem number 1 in your journal. Problem number 1 is dealing with a two-dimensional vector. You have 3, 6, and then we have, I believe, -4, 2. Just remember, the 3 represents what's called your horizontal component, and the 6 represents your vertical component. So on problem number 1, even before we do the math part of it, as far as just the calculations using a formula, I want you guys to graph these. I want you to see what they look like on a graph before we actually do the math. I'm going to highlight one in green. Do this one in green. I'm going to do this one in this purple color. Now I'm going to create my vectors. From right here, from the origin, I'm going to go over 3 units horizontally, and I'm going to go up 1, 2, 3, 4, 5, 6 vertically. So that vector has a horizontal component of a 3 and a vertical component of a 6. Now I'm going to do this vector. From the origin, I'm going over 4 in the horizontal direction, the negative direction, and up 2 in the vertical direction. All right, now what we need to do, guys, is we need to look at our formula. So I'm going to go right back here. It says the inner products of vectors in the plane. So right here it says if A and B are two vectors, vector A is written as A1, A2, and vector B is written as B1, B2. The inner products of vector A and vector B are defined as so. So right here, this is the formula you need to write down in your journal. Right there. A1 times B1 plus A2 times B2. That's what I want you guys to write down. I'm going to zoom in on problem number 1, and we're going to use that formula. Now, we've already done problem number 1 with the graph. You saw the graph. In case you wonder what the graph looks like for problem 1, there it is.
You have to do A times B equals A1 B1, or just the A1 B1 plus A2 B.
I will show you. The inner products of this are A1 times B1 plus A2 times B2. Now, before you do this, very important that you label things correctly. This is A1, this is A2, this is B1, this is B2. So before you use the formula, make sure you label things nice and neat. So A1, you're right, no, A1 is 3. B1 is a -4, so I'm plugging those in. A2 is 6. B2 is 2. So after I've labeled them, now I'm carefully plugging them in. I get a -12 plus a 12, which yields me a sum of 0. Now 0 is the very important number in this. If your sum of inner products, if the sum of these are equal to 0, that lets you know without having to graph it that these are indeed perpendicular to each other. So, but yes, they are perpendicular. If the sum of the inner products are not equal to 0, then the answer is no. They are not perpendicular to each other. All right, the next thing I want you guys to do, I'm going to zoom out. I want you guys to look at the inner products of vectors in space. In space means you're not dealing with 2 dimensions, now you're dealing with 3 dimensions. So right now, write this down nice and neat, and we're going to zoom in on number 4. So I'm going to zoom in on number 4. Here we go. On problem 4, you're going to put this one in your journal. You're going to call this A1, A2, A3, B1, B2, B3. This right here, everybody, is referred to as vector A. This right here is vector B. This is your horizontal component. This is your vertical component, and that is your depth component. This is your change in X. This is your change in Y. This is your change in Z.
Is this inner?
This is the inner products, the sum of inner products of vectors in space. Now we're not dealing with 2 dimensions. Now we're dealing with what? 3. So you guys remember the previous one we had, say, the Y, we had the X, right? And then we had the 3rd dimension. It's kind of hard to see right here, because that would be a right angle. This right here would be a right angle. This right here would also be a right angle if I called this X, Y, and Z. But it's hard to draw things in 3 dimensions on a 2-dimensional plane. So I'm just going to erase it. This is the concept. Now, I'm going to write down the formula for you guys. Vector A times vector B, if we're doing the sum of inner products. Here we go. A1, B1, plus A2, B2, plus A3, B3. It's basically the exact same formula that we just did before. The only thing is you're just adding one more what? One more dimension. That's all we're doing. Now, right now, what we are doing is we're finding the sum of the inner products. The reason why they call them inner products is I'm literally multiplying A1 times B1. I'm multiplying A2 times B2, and I'm multiplying A3 times B3. All right? Those are the inner products of these 2 vectors. So A1 is what? -2. B1 is 3, so that gets me a -6. A2 is 0. B2 is 2, but 0 times 2 is 0. And A3 is 1. B3 is -3, that gets me a -3. When you add all of those together, you get -9. Now that is the sum of my inner products, but the answer would be no, or not perpendicular. But not perpendicular. Now, if you wanted to, you could say right here, there's the upside down T for perpendicular. That's not perpendicular. So there's 2 answers. I want to look for this answer to see if you actually were able to get the correct inner product. And if that's not 0, then they are not perpendicular. The next thing we're going to talk about is going to be dealing with cross products of vectors in space. Right now, I have vector I, vector J, vector K. These are all unit vectors. This is your unit vector for the horizontal component. This is the vertical component. That's the depth component. I'm going to highlight vector I in blue. So right here, A1 and B1 will always be in blue for my problem. Okay? For J, I'm going to use red. So right here, I'm going to use red for J. And for K, I'm going to use green.
So you want to do that?
That's what I want you to do in your journal so it matches, so you have things nice and neat and color-coded. Now, problem number 7, I'm going to do right here on the board. Problem number 7. We have 2 vectors that we're going to be finding the cross product of. One of them is 1, 3, 4. I'm going to call that vector A. All right, this is vector A. And the other vector is -1, 0, -1. And that right there is vector B. Now, what I'm about to do is I'm going to write the formula for what is the cross product for vector A times vector B.
We're doing number 7.
We're doing number 7 right now. I'm going to put it right here. This deals with the I component. The next thing I'm going to do is these symbols are for the determinant. This is going to be a determinant symbol that you did with matrices way back in the day. All right, this is going to be the J component. And last we're going to do is the K component. Now you're going to notice something in these determinants. This is a minus and this is a plus. Those are very, very, very important. I'm going to highlight those in orange because it's a totally different color. You don't have to highlight them if you don't want to, just highlight them so you see it. Okay? Now, what I'm going to do is I'm going to write down the formula that you've already written down in your journal. So here we go. This one is going to have A2, A3, B2, B3. So I'm not coloring anything yet. This one over here, J, will have A1, A3, B1, B2. And K, right here, will have A1, A2, B1, B2. Now, I was able to do that by memory without looking at a paper because I already know the pattern. Now, I want you guys to notice a certain pattern. I is colored in blue, right? The cool thing about this, my blue column right here, if I'm dealing with the component for I, I'm not going to use the blue, I'm just going to use the red and the green. Because I is blue. If I go over to this one, J is what? J is red. I'm not going to use the red. I'm going to use the blue and the green. So if you're at J, which is the middle one, which one do you use? You use these on the outside of them. K is in what? K is in green. And I'm not going to use the green. What am I going to use? The blue and red. Okay. Now, right now I'm about to start the most important thing before we start plugging things in. Here is the most important thing. You need to fill in I, J, and K. So right now, I'm going to fill in what is going to be the numbers we are in the I column, what are the numbers going to be in the J column, and what numbers are in the K column. So right here, I'm going to write a 1, a 3, and a 4 from the 1, 3, 4. Here I'm going to write -1, 0, -1. This is the most important part because this is what I use to help me plug in the correct numbers every single time. All right, what am I going to plug in for A2 and B2? I'm going to plug in a 3 and a 0. What am I plugging in for A3 and B3? 4 and a -1. Here I'm going to plug in a 1 and a -1. Then I'm plugging in a 4 and a -1. Just using the colors now. A1 is 1. B1 is -1. A2 is 3. B2 is 0. Now I'm not going to color code these because I actually got to do the math now. I don't want colors all over the place. This is a 2 by 2 matrix. A 2 by 2 matrix has to be solved. The determinant has to be solved using this process. In order to find the determinant of a 2 by 2 matrix, you have to do A times D minus B times C. This is back dealing with matrices. So you have to do A times D minus B times C for every single one of these. So I'm just going to highlight it right now so you know what you're going to be multiplying and then subtracting. Looks like I'm going to run out of time on this video, so we're going to continue this problem on the next video. We're going to be doing a 2 by 2 determinant for every single one of these.
Like fraction?
No, determinant.